If you have any question, you can ask. Okay, so this is the thing. Now what we said, what we are doing activation function, transforms neuron input to output. So it's a kind of a switch. As I said, that we have this. This is input. This is bias. So this is the series summation. This is the end of activation, and this is the, so this is the activation. Activation. So it's a kind of switch. So features of activation function is a squashing effect is required. Prevents accelerating growth of activation levels to the networks. Simple and easy to calculate. So this is very that much. This is the activation function. As I said, the sigmoidal, how actually sigmoid works. That if it is greater than some threshold, it is +1. It is less than some threshold, it is 0 or -1. Depending on that. So the same thing. This is not activate state. This is active state. So this is the thing of activation. Now here you can see the different activation functions are being said. You see here that this is a step function, that if it is a greater than this threshold t, this particular threshold t, then it is a greater than threshold t, then it's become +1, otherwise it is a 0. So it is greater than t, it is 1, and less than is equal to t, or equal to t, it is 0. It is called step function. Now sine function, definitely you can understand, it is a greater than is equal to 0, greater than 0 it is +1, and less than 0 it is -1, and there is some sort of surfing at 0. So it's not continuous. This is sigmoid, as you see. This is, let's say, it's a 0.5. This is 1, and this is 0, and this is, you can say, and this is +1. This you can say it is +1 and it is 0. So if it is a greater than 0.5, greater than is equal to 0.5, it is closing to 1. Is less than is equal to less than 0.5, is closing to 0. So this is the idea of the activation function. This is a sigmoidal activation function. And we see the different aspect what is a sigmoid. In logistic regression also we see that how actually the sigmoidal, we impose the sigmoidal nonlinearity over our linear equation kind of thing. Hypothesis function. Okay. So the activation function is one of the major thing that we intend to understand. Now, standard activation function, what are the hard limiting threshold function? This corresponds to the biological paradigm, the either fires or not. That we said, depending on the fire, depends on depending on a threshold. Okay. So sigmoid function shape is this. This is sigmoidal that we know very well that phi x is equal to 1 by 1 plus 1 to the power minus ax. Minus x also, a is basically the kind of, is a logistic function. The hyperbolic tangent is symmetrical, or both functions have a simple differential. Only a shape is important. So this is basically the idea is that. So this bias term will basically try to understand that we already said the bias term. Bias term is basically this, that I said that there is a shift here. You can say this is a shift. So this is the bias. So it will be much easier to understand with what we have said. That it is our mx plus c, and bias means it will go in this same similar thing, but this is the bias term actually. So exactly here also, if you this is a single line, so if it is a plane, so you can see this is a there is a there is a this vertical shift here. So its plane is somewhat breaked in this way. So this is called the biased. Okay. So we'll carry on this discussion. Okay, in the next class, we try to understand next class the training of this singular, how it is being trained in next class. Thank you very much.